Welcome back to another growth rate model tutorial. In this tutorial, we will learn to generate a flame structure. A flame structure can be represented in a mixture fraction space and in the radial space. It consists of flame temperature, combustion species mass fraction, and either the mixture fraction or the burner radial distance, depending on the mode of flame structure that you're going to plot. Within this flame structure, there is the high CNT growth region, which is represented by this shaded region. So we also have the same shaded region in the radial space based flame structure. Note that we also have a small arrow over here, which we will relocate to indicate the blue plot belongs to the temperature. We will generate these flame structures using MATLAB. Again, there are two modes of flame structure, and so there are two scripts for each flame structure. So for the flame structure in the radial space, the code will require you to input your txt file. You will rewrite this variable over here according to the name of the .txt file for your CFD data. The next section of the script is the temperature plotting. You can specify your x-axis range. For example, I have 0 to 9 millimeter in the radial distance. So once you change this line, you need to also change the following line. And then you can also specify your temperature range. This range is in Kelvin, 300 to 2600 kelvins. If you have maybe 400 to 2000 Kelvin, then you can change it accordingly. So once you change that, the upper limit must also be changed in this section of the code. Note that if you also change the x-axis limit, then you need to also change the limit over here. This section of the script are needed because for some reason, when MATLAB attempts to plot two y-axis and one x-axis using the xyy plot command, the top boundary of the plotting window disappears. So I'll show you what that means. Let's just comment these lines and rerun this code. As you can see, this top line disappears. So to make that appear back, we have to uncomment this line and rerun the code, and there you have it. For the axis labeling, just leave it as is. Now for the species plot, you can add more species according to your results. For example, if I have another species called OH. By the way, the naming of these species depends on the variable name in the workspace. P0, P1, P2, and so on and so forth are the handles for the plot. It is to make your life easy when you want to generate the legend. If I have P5 is plotting for OH, then I can say in the legend section here, P5 represents the OH species. And if I add more species, then we can add up on the legend section accordingly. But let's revert back to the original version for now. You don't need to tamper with these settings. So this is where you specify the shaded region. Instead of painstakingly drawing all the lines of the high growth region, you can automate this process using this section of the code. So we will look into first defining the left boundary and the right boundaries of the high growth region.